thank you for coming back from the coffee break and coming to my talk. So today I'm going to talk about the JIT compiler and its improvements in Ruby 2.7. So maybe this is the first time to come to Russia for me, so maybe you may not know me, so let me introduce myself. My name is Takashi Kokubun, and because Takashi is the very common name in Japan, I chose Kokubun as their identity for me on the internet. And I'm working for ARM, which acquired formerly Treasure Data, which did kind of Rails applications and Rubies and stuff. And probably you may know me as a maintainer of the ELB template engine. Probably you're using it, and also Hamo. I kind of rewrote Hamo 5 and optimized the performance by 3 times faster. And also, I'm the author of the Hamlet template engine, another implementation of Hamo, which dropped a lot of legacy stuff and runs faster. And I'm also, for this recent 2 years, I've been working on the Ruby's JIT compiler, mainly. And this is my last 2 years, or 2.6 and 2.7 commit graph, and I'm next to Nobu, who is always the top committer of Ruby. So I'm second to him. And actually, many of our top committers are mostly full-time Ruby committers, paid for delivering Ruby, but I'm not paid, so it's hobby work for me. Anyway, so JIT stands for just in time, and which also means a compiler after that. And I started this work because I wanted to improve the performance of Rails application, because I've been developing Rails application. So I was a Rails application developer for a long time, and then I still write Ruby, but also maintain Rails applications. So I'm interested in optimizing Rails for my company and my hobby stuff. And in the first keynote, Matt said JIT is mainly for our, JIT can optimize the performance of research purposes, research computing purposes, but my main interest is for optimizing web applications. So I'm very struggling to improve the performance of Rails applications or whatever web applications like Sinatra or Hanami. So the feature is very easy to use, or maybe the simplest feature ever. This can be maybe once this is stabilized or more optimized, maybe this can be enabled by default in the future. But right now, you need to specify --JIT. So how many people have ever used the JIT feature or at least tried once? Okay, some people. Anyway, so this flag just enables the JIT compiler thread, and the JIT compiler thread monitors the frequently executed methods to optimize that to our C code. And so instead of letting you write a C extension, you can just write Ruby, and JIT compiler thread automatically converts that to the faster C code. And JIT compiler thread can dynamically lower the C code to the memory. And after that, Ruby interpreter calls the native code, which is compiled from the original Ruby code to the C code. So it's supposed to be faster. And it's introduced in the Matt's keynote, but it's a benchmark. There's a benchmark for measuring the progress of Ruby's performance. And this is an NS emulator written by Endo-san. And so the formerly, or not formerly. This is the latest, 2.6 performance with virtual machine. If the graph goes higher, it's faster. And by just passing the --JIT, it becomes like 1.6 times faster. And thank you. So this application is very CPU intensive because this renders each pixel in every frame, so very CPU intensive, and there's many rooms to optimize in a CPU level. So as said by Matt, current JIT compiler is kind of suitable for this kind of optimization. And right now, not suitable for optimizing memory usage or I/O bound. Actually, I don't think I/O bound can be resolved by JIT compiler, but actually, memory access might be able to be optimized because we could eliminate the memory access for some situations, which is not, in some edge cases, or in some cases, which we can assume something in major situations. So, and the weird thing here is that, as I said before, this JIT compiler converts the Ruby code to a C code first. So to load the C code to Ruby memory, Ruby's interpreter, we need to execute the C compiler on runtime to generate the native code. So once you pass the --JIT flag, you may see weird child processes like GCC and CC1 and AS. Maybe you may feel it kind of security attacked or got strange, but it's currently intentional. In the future, we may be able to do something to preload that kind of native code, but right now, we don't support that kind of thing, so you will see this kind of process tree after enabling the JIT compiler thread. So behind that, I roughly explain how that works. Once the --JIT is, this is a build process. So when you install the Ruby interpreter, the virtual machine code is compiled, precompiled to the precompiled header, and this is can be loaded faster from the JIT compiler. And in the Ruby process, by enabling the --JIT, that invokes mjit worker thread, which leaves aside the VM thread for executing your Ruby programs. And mjit thread waits for the compilation queue to have frequently executed methods. And when it finds a very hot method, it generates a C code, and it dynamically executes a C compiler to generate a .o file, and then link it with libruby and native C, libc, and things like that. And then loads to the memory by the function called dir_open, but you don't need to know the underlying functionality. But anyway, it yields a kind of function pointer, and so that virtual machine can call it directly. So this can be easily used, like just passing --JIT, but sometimes you are not executing a Ruby command, because you can also use Ruby as just a Rails command or bundle or gem or whatever. So in that case, you may want to use a Ruby virtual environment variable to specify the --JIT flag. So it's very easy to use, and in the future, it may be just default. So you can just leave and forget it. But I'll introduce some optional features to be used. By passing the Ruby long --help, you can see full options, but you don't need to remember this. But the most important option here is JIT verbose option, which can specify the level of the verbosity. And by passing the verbose 1, it is the kind of my recommendation for user usage. And it prints the compiled method and how long it takes to be compiled. And then also, it prints some other information like what methods are inline. And actually, this inlining is a new optimization in Ruby 2.7. Also, it also brings a thing like JIT recompile. It means discarding the too much optimized code to less, more conservative code to prevent JIT from canceling a lot. So this is also introduced in Ruby 2.7, and also you can see JIT compaction in the end, and it's kind of a word which is implemented by me. So this is the real thing, original in Ruby 2. Ruby. So in Ruby's JIT, when you run a Ruby program with -JIT for a long time, that leaves a lot of .o files, which is native code. And the reason I leave the .o files for a long time is for linking it all together later. So in Ruby 2.7, it can compile 100 methods to native code, and so that may leave 100 .o files, and link it all to the same single .so file to load it to the kind of close, compacted memories. By doing that, it improves a lot of memory access performance, because if it's very close, the cache efficiency will be improved by that. So this is called a JIT compaction, and maybe you need, if you want to benchmark the Ruby's JIT, you may want to wait for this JIT compaction to appear, because it significantly improves the performance. So, but as shown in the Matt keynote, I have a hard time for improving the performance of Rails, and I'm going to explain why and how it's slower right now. So I kind of prepared, JRB team originally had a Rails benchmark, which is just a Rails scaffold of a show action, and I kind of modified it to the Rails 5.2, which is actually old now, but I should make that to Rails 6. But anyway, it's just a Rails scaffold. Just show read a record, one record from a database, and show that, and you may be using the Rails scaffold anyway. So. In the Ruby 2.6, Ruby 2.6, the performance was like this. When JIT is enabled, the right side is a JIT, and the higher is faster, so this means much slower. But in 2.7, currently, the performance is like this. So it's still not faster yet, but kind of following the VM performance. And this is because by enabling the JIT compiler, we get another bottleneck or overhead for loading native code from memory. So I need to offset the overhead by something by optimization, and I'll explain that later. But once we solve that kind of overhead, I think we can continuously improve the Rails performance on the offsetted base performance. And also memory consumption, I want to mention the memory consumption. It almost does not increase the memory consumption, and I think it's very positive result. Like it can be easily used in production without increasing the memory consumption a lot. And it's similar in the 2.7, and I think it will not be increased in the future either. And the main reasons of the slowness right now is cache inefficiency. So when programs load something from memory, it does not load every time to the CPU, but it has some level of caches in the CPU, and so it can cache some of the memory to the CPU. But the resource is limited, and if we have a lot of things to be loaded to memory from memory, the cache is overflow, and it's inefficient. So if the memory access is not cached, it becomes significantly slower. So by having a lot of native code in memory, and also loading that for every method call, JIT method call, it becomes slower. And I'm going to explain that later, but also Rails have a lot of methods, and so it increases the cache pressures the too many methods and cache efficiency. And besides, the Rails application workload is less CPU bound compared to the opt-carout, former benchmark, and also kind of IO bound and just wait for, sometimes just wait for the databases. But I believe that still, it's not just, Rails is not just a wrapper of IO operations and have some VM operations and memory accesses. So I think we can improve the Rails performance by having some optimization in JIT compiler. And the current situation is that we haven't worked on that all of the possible optimization yet. So I'll explain what I've tried or done in the Ruby 2.7 development. So I want to explain 5 things here. Actually, I'm doing a lot of more things, but these are the 2 things I'm going to explain today. So the first 2 things are a very simple one, and the other 3 things are more major ones, and the 4 is the kind of newer stuff, and which is hoped to resolve the current bottleneck in the Rails applications, and it is, this is the first time to show to the public talk. Anyway, I'll start from the first one. So default option changes. Actually, for improving the Rails benchmark, this contributes a lot. Like, so there are 2 minor JIT options, which is configuring the number to trigger the JIT compilation. Like in Ruby 2.6, it requires 5 times to call a method to be JITed, but in Ruby 2.7, it became the 10,000 method calls to invoke or trigger JIT compilation. And also, there's also a JIT max cache, which is the number of methods to be optimized or JITed. But compiling the 1,000 methods to native code and rolling that from memory is increases memory pressures, and it's not cache efficient. So it's decreased, but maybe that may be changed later if we solve some overhead in the dispatch method dispatches for JIT code. This number originally came from the JVM. JVM also requires 10,000 method calls for C2, the last higher JIT compiler. And the code cache size is not so big for JVM as well. And the second one is called de-optimized recompilation. I showed that as a log of the --JIT verbals1 as a JIT recompile. But the recompilation is, so JIT has a lot of, speculates a lot of things. Like integer plus is not redefined, and this method is not redefined from the JIT compilation. But sometimes people do weird things like overriding integer plus to something weird. And in that case, we need to discard the native code because the JIT is fast. JIT code is fast because we speculate that kind of things which is useful for optimization. And must say type information is not helpful for optimization. I kind of agree with that, because even if we had a type information in the, we can ingest it. Even if we can ingest the type information to JIT compiler, we know the variable can be is an integer, but in that code, we may be able to have a subclass of an integer, and in that case, the method call needs to be rechecked, and the method cache cannot be reused for subclasses, and it is not so helpful for optimizations. But in the just-in-time compiler, we have the exact type information, like this is not the subclass of the integer, because we have a method cache, which is maybe you don't need to know the mechanism of method cache, but it just captures which exact class is used in this line, and also which method entry is used in this, and which is not defined or not. And so we can use that kind of information to generate a very optimized code for this exact process of the situations. And in Rails application, it has a lot of dynamic things like eval on runtime. So that kind of speculation may be invalidated on runtime, and in that case, the JIT code becomes just very slower. So that can be one reason to make Rails applications slower, and I added this mechanism to avoid that kind of slowness. So this is a debug counter, which you don't need to use. Anyway, this is an internal counter to measure what number of JIT method calls are invalidated. And this under mjit underbar cancel is 2 million times. For this measurement is for 10,000 Rails application requests. So kind of a lot for compared to the JIT calls in the top of these numbers. And I wanted to make the cancel 0. And when this happens, this is the actual code of the Rails application. Rails core, concurrent Ruby, and yeah. So if there's a blanket method, this can be used in multiple subclasses like MRI map backend and map implementation and concurrent Ruby map and things like that. So, and also, Rails also has a subclass of the concurrent map, and which is also used, both are used in the Rails core. That means that the blanket methods entry can be used as multiple classes, and we cannot speculate that the instance variable is not for concurrent map or small cache. And the decompilation, when decompilation happens, this optimized speculation is invalidated, and it's converted to the more generic one, which is kind of slower, but still allows to execute other places to be faster. And this is actually originally in the original version of the mjit, which is proposed by Vladimir Makarov. And the first version of the Ruby 2.6 JIT compiler is kind of simplified to reduce the risks of the release. And so this mechanism is dropped, but I reintroduced that to the Ruby 2.7 for optimizing the Rails application performance. And when you measure the Rails application performance or enable the JIT compiler in the Rails benchmarks, you may see this kind of JIT recompile to show, indicate that real compilation is happening. And after that, the cancellation becomes just 0, and it's always executed on the JIT compiled mode. So I believe this helps the Rails application performance in 2.7. The next thing is already in the master of the Ruby 2.7. By the way, Ruby development branch is named from trunk to master, so I never call development version as trunk. Anyway, method inlining is for optimizing the overhead of the method call. So Ruby's method call is very dynamic and complex, and therefore is a little slow compared to just normal C function call. It takes about some nanoseconds to some tens of nanoseconds, and you don't need to remember this, but so example situation is like numeric 0 is much slower than equal 0. I don't care this at all, but this is reported as a bug. I don't think it's a bug, but JIT compiler is supposed to optimize this kind of thing to make programmers happier because some people prefer to use zero question to kind of Ruby-ish, write a Ruby-ish code. And so I wanted to achieve that kind of thing by optimizing Ruby performance and let people stop worrying about performance by themselves. And the solution for this problem was, for me, in this case, was method inlining. By using the method inlining, the zero question method code can be just converted to the equal zero because the definition is the kind of same, or actually at least the functionality is the same. So by using the method inlining, the method call overhead is just disappear, and this can be just faster. And how it works is currently the method inlining is supported for methods defined in Ruby. And some core methods like zero question is currently not defined in Ruby and just written in C, but once we rewrite the C core to Ruby, that can be inline, and it means that Ruby can be faster than C language for some situations. And it's much happier for Ruby developers, Ruby core developers. Anyway, but this requires some effort to optimize or improve the Ruby virtual machine implementations. So this equals is executed as a virtual machine instruction called EQ, just EQ, opt EQ, but which is supposed to cause a side effect. It's expressed as a leaf in the virtual machine implementation. But in Ruby 2.7, I did a lot of effort to turn the side effect flag from false, from this true means no side effect. So I flagged, switched from false to true for many instructions to achieve this kind of inlining for Ruby programs. And now Ruby 2.7 can inline this kind of method if the method is defined in Ruby, but currently zero question is not written in C, so I need some work to allow using the Ruby version of the zero question for JIT compiler mode, and so this is not closed yet. Anyway, once we define the Ruby version of the zero question, that generates the JIT inline, as I showed in the JIT purpose one. It improves the performance a lot. So the bottom lower version is faster than the original equal zero. So now zero question can be faster than the equal zero. But the problem is still JIT can also improve the performance of EQ, so equal zero is still faster, but still the performance difference became same-ish, so you can forget this kind of minor trivial optimization like converting a zero question to equal zero. So for making this more efficient, I need to work on more to change the virtual machine implementation to make many virtual machine instructions to be free from the side effects. The main part of this today is maybe this one, optimized dispatch of JIT code. So I said the current bottleneck in Rails application, JIT on Rails application is memory access becomes slower by having a lot of methods to be compiled and loaded from the memory. But this kind of problem cannot be solved easily because I'm hired by a CPU company, but I'm not familiar with optimizing the hardware, so I just need to live with the current performance of the memory access. And instead of optimizing the memory access, I decided to optimize other places to offset the overhead of the memory access. So formally, this is not a current version, or even not the Ruby 2.6, but this performance graph is, the orange graph explains the time that takes to call a method just returns nil. So there's no room to optimize this kind of method, but by just having a lot of methods in memory, the method call overhead is significantly slower, becomes significantly slower. And so this means that when there are 100 JIT methods in memory, the method call overhead becomes very larger, almost double maybe. But actually, this is solved in the Ruby 2.6. Like, as I said before, there's a mechanism called JIT compaction, and links all the .o files to .so file, and reload all native code. By doing that, this kind of similar. It significantly improves the locality of the JIT memory. So it improves a lot of performance here, but still a little slower than the gray virtual machine version. I see some performance metrics that indicates it's slightly waiting for memory load. So this is a kind of major problem I've been worked very hard to solve to optimize Zero's applications. And I believe once this problem is solved, we can just improve a lot of places, and there will be no degradation in the major situations. So the first approach for this one was suggested by Noor, and this is this mechanism is using the GCC or CLAN's profile generate option and using the profile use option to reuse the kind of profile on the runtime for native code level. And but actually, for MJIT generated code, it does not help, I found from the investigation. So I just dropped this option for now. And the current approach for this was is optimized. I'm calling it as optimized dispatch of JIT code. So calling the JIT code is slower when it's called from a virtual machine, and that's because so when JIT code is dispatched, that needs to load a Ruby code representation, which is called instruction sequence, to memory, and also native code for dealing with that virtual machine. And that means that just increases the number of the memory accesses, and so this becomes slower when just JIT is passed. But the implementation is just the same as the original version of the MJIT, so I found some rooms to improve the performance there. And at least when the JIT code is dispatched, there are two indirect dispatches in the implementation. And I found we could reduce the two indirect dispatches to just one indirect dispatch just for invoking the native code. And so I'm trying this approach right now. So by doing that optimization, the graph becomes just lower, and it's always faster than the VM method calls. So I believe the method call overhead will be improved by this approach. The problem actually here is that by enabling the --JIT, we also need to profile the number of method calls. So this is talking about the JIT method calls, but virtual machine method calls may be still slower even after having this approach. So I need to investigate how it will go after having this approach, and also think something for improving the usual virtual machine method calls. So I think this will be if once it's introduced in the Ruby 2.7, it's very promising, I think. The last one is stack-based object aggregation, which is kind of POC right now, but it's just pending because this is more important thing for improving the Rails application performance, and so I've spent a lot of time for this and pending this one. Anyway, but I believe this also helps the Rails application performance because Rails application allocates a lot of objects on runtime, and memory access is very slow compared to CPU calculations. And this performance metrics indicates that Rails application takes a lot of time for GCs and memory allocation for malloc. And this optimization approach is allocating the object on stack instead of heap. Stack is the kind of same as the backtrace. When you are using the Ruby program, you may see the backtrace when exceptions are thrown. The stack is stored in the same place, or except backtrace is kind of stored in the stack, and we could have the same thing in the stack. So that means that we can allocate the object when the method call bumps the stack frame, and it's deallocated after the method call is finished. So it's faster compared to using the heap, because when using heap, program need to randomly find a free space and manage some kind of list to manage which block of the memory is used and not. And this is complicated compared to the stack bump and decrease. So stack aggregation is faster, and by having that POC, I benchmarked this kind of thing. Like sometimes you may want to write the lower array 1, 2, 3 and include question to examine something. But for some performance enthusiastic people do the above to avoid the object allocation for arrays. The latter part of the benchmark allocates the array every time when the line reaches this one. But I wanted to optimize this for make programmers happier. So by introducing the stack allocation, originally the array version, allocating version is 1.4 times slower than the kind of cached array version. But by having a JIT compiler, it becomes faster than the original cached version. So maybe you may be able to forget this kind of minor optimization, but it also improves the cache array include as well. Anyway, the difference becomes slower, and so I hope people can forget this kind of minor optimization in Ruby Rebel. And another example is that maybe you may like to specify .freeze to avoid the string allocation for immutable usages. So it was popular to specify .freeze for Rails core, but I believe this should be solved by Ruby interpreter instead of the Ruby programmers, because writing .freeze is very not clean and very dirty. So I wanted to help you not to write this kind of thing. And by having this stack allocation, without freeze, it becomes even faster than the original .freeze version. But also improves the .freeze version. Anyway, but anyway, stack aggregation improves this kind of offsets the 1.5 times slowness by just enabling just passing the --JIT. It's still work in progress, but I kind of have the basic idea to implement this, so it can be introduced very soon. But I'm currently working hard to the fourth option for optimization, because that's the main bottleneck for Rails. So let me conclude this. I'm working very hard to the fourth option, optimizing the dispatch of the JIT code, which is supposed to solve a lot of bottleneck of the Rails application with JIT compiler. And once the current bottleneck is solved, there will be no major thing to degrade the Rails application performance. So I believe I can introduce a lot of optimizations to improve the performance based on the baseline, not slower than the virtual machine version. So that's it.
Thank you, Takeshi. Now we have 5 minutes for questions, so please be fast.
Thank you for the talk. I had one question about in method canceling, JIT canceling. Did you have any thought about joining the efforts of static type checkers and marking the methods in signature file with some metadata which tells that this method is frozen and it shouldn't be overridden with metaprogramming or something else, or any kind of metadata to mark instance variables methods as not causing canceling? Thanks.
So maybe that can be helpful for ahead of time compilation, because we can know the metadata ahead of time, but in JIT compiler, I believe it is not so helpful because we can know the more specific information from the method caches in the runtime, because we always know, we trigger the JIT compilation after 10,000 of the method calls. So I hope all the method caches are just populated, and I hope the interpreter knows, or JIT compiler knows that this line is not just integer, it's not subclass of the integer, but the exact integer class. Something like that needs to be known for optimizing the JIT code. But I believe the V signature may not have that kind of too specific information, because integer is compatible with the subclass of integer. So I believe method cache is more efficient for knowing that kind of thing.
Hello, Takashi. Thank you for the talk. Is there any part of Ruby on Rails framework that already gets performance improved because of JIT, maybe routing or template rendering? And does Haml works faster with JIT or not?
Sorry, could you repeat the main part of the question?
Is there any part of Ruby on Rails that already get performance improved due to JIT?
Yeah, I also want to know that, but previously I examined or prepared or broken down the Rails benchmark to active action view and controller and sprockets and seeing other things, but I don't remember. Maybe at least I didn't see the significant improvement in any of the components yet. So maybe this is because we don't have this one yet. So I hope once we have this optimization, the single component of the Rails can be at least improved. And I want to measure that again after this.
Thank you.